Well, graphing and working with absolute value functions. This is your next section. This video will be directed towards notes. Now, the absolute value function is one that we haven't worked with yet. However, we have worked with the absolute value sign. We remember this as absolute value of x, and this was the directed distance, or the total distance away from 0. So the absolute value of a negative 2, we remember, is 2, as well as the absolute value of regular 2 is also 2 units away from 0, so both are equal to 2. The general graph of this is going to be the graph y equals x on the right hand side, everywhere where x is greater than 0, and it's also the piecewise function, sorry about that, y equals the opposite of x for everything less than x. So again, this is a piecewise function, f of x equals the opposite of x if x is less than 0, and positive x if x is greater than or equal to 0. Okay? So there is that graph. Now, the equation that we use to make this graph, and the equation that we use, the y equals, is y is equal to a times the absolute value of x minus h plus k. And in this form, we have a couple of different characteristics. First off, let's look. We have the absolute value sign. So we know that it's going to look like a V. Okay, it's going to look like that type of graph. We have a variable a that we'll get to, but I want to start off with h and k. If you remember, the graph of the absolute value function is basically a V. And down here at the bottom of the V, where we turn the corner, this is called the function's vertex. And the vertex will always be an xy coordinate pair ordered h, k. To keep this straight, you might think hk, they're right next to each other in the alphabet. No, well, it's h-i-j-k, oh well. It's h before k, just as we have x before y. Okay, so h is always going to be associated with x, and k is always going to be associated with the y. Our vertex, or this corner point, will always be at hk, no matter what those values are. So if we were to have the function y is equal to the absolute value of x minus 2 plus 2. Okay, again, looking at the similarities between our top function and the bottom function here. A, we don't see a, but we assume it to be 1. Okay, so a is 1. This will be the same type of graph. X minus 2, well, we have x minus h. So we know that the h value is equal to a positive 2. Okay, it's following the same form. Okay, and the k value, we have a plus k, right here we have a plus 2, so we know that k is also equal to 2. So the vertex of this graph would be at 2, 2. So it's this graph here, only we'll shift it 2 to the right and up 1, 2. Okay. An example there. So again, properties of the absolute value function are that it has a vertex, or the corner, at the point hk. Next, we're going to talk about the a value. Okay? Because the a value does quite a few things for us. Number one, a determines how the function opens. And here's how A determines that. If A, say, is a negative value, so if A is negative, we are going to open down, okay? So instead of the regular y equals the absolute value of x function, it will open instead down to some degree, okay? And if A, this quantity A here, is positive, then we will open up. Okay. Those are our first set of properties with A. The second thing having to do with A. Okay. A also determines how skinny or how wide this absolute value function will be. Okay. A determines the, I'm going to call it the size of this graph. Okay. And that means if A is less than 1, okay, if A is less than 1, what we're going to see is a wider type of graph. Okay, and down below, if our value A here is greater than 1, we will have it's a more slim graph, a skinnier graph. We're going to go from y equals x, and if we say y equals 2 times x, now it's y equals 2x, or y equals a negative 2x. So it's a skinnier graph. Okay, we're going to look at a skinnier graph. Now, in the next video, we're going to look at some examples of these.